So let's go over activity number 5 together in case you are not able to finish everything by yourself. The first problem asking you to identify whether this is a one-to-one function or not. You have two ways to think about it. The first way is to use the graph and hence the vertical line test. It's pretty obvious that the function has the graph, which is essentially 2x squared shifted downwards up to 8 units. Therefore, the graph of the function can be easily plotted like this. So you can see based on the horizontal line test, I could have identified two different inputs, which was x1 and x2. They share the same function value, so it violates the vertical line test, and therefore it is not a one-to-one function. The other way of looking at it is you can simply propose two different two different inputs, which results in the same function value, which is something looks like this, and therefore you end up with f of 2 being the same as f of negative 2, but 2 is not the same as negative 2, so which is essentially the horizontal. My bad, I should have said horizontal line test. Vertical line test is about testing the graph being associated with the function or not. So either way, you are going to get to the key part, both of which has demonstrated that there are two different inputs generating the same output, which essentially violates the definition of one-to-one function. Therefore, it is not a one-to-one function. Okay, that's the idea. Okay, second part, we want to find inverse function, which is given of something that's given like this. Well, we said the general idea, which is something that usually works, is you change the notation into x being y over 2y plus 3 first, and then what you do next is essentially one more time, you change all the x into y, you change all the y into x, and you keep going with your calculation. You want to make sure you have your y standing by itself, which means you want to get rid of it from the denominator so you can do whatever you want by shuffling y around afterwards. So by doing this, what you end up with x times 2y plus 3 equals y. Keep thinking that your y is buried in the parentheses, so you can't really shuffle this to the other end. So the only thing is I make sure that my y is no longer buried in a parentheses, and now I have the freedom to move them around, which means 3x is y minus 2xy. Now you reach the stage where all the y terms were on the same side, so all you need to do is factor it out. The 3x is y times, be a little bit careful, this is a very common mistake. You factor out y, there's still a 1 left, minus 2x, hence you end up with y being 3x divided by 1 minus 2x, which is essentially the inverse function you are trying to identify. If you want to find the range of the inverse function, it's the same as asking you what's the domain of f function. They are essentially the same idea. Domain of f is whenever your denominator is not 0, so 2x plus 3 is not 0. Hence, everything except x being negative 3 over 2. So this is my answer to the second question we have here. The next question is also relatively straightforward, even though there is a wide range of those types of questions. So first of all, you are given the domain of the function. You are looking for the range of the inverse function. As we said in class, they are supposed to be exactly the same thing. And if you are looking for the range of a function, then you need to find the domain of the inverse function. The domain of the inverse function, which only has a denominator, so the denominator is not 0. So you are throwing just 0 away. The next problem, the following statement are true and false, right? True and false, T and F in front of below each statement. So we can find inverse function of any function which is not necessarily true. We can only find one to every single one-to-one function. Therefore, this is a false statement. The next problem says f negative 1x is that, which is not true. The F inverse notation is reserved to represent the idea of inverse function, just like the letter E is specially reserved and the letter pi is specially reserved in mathematics to represent something extremely special. The function f of x is 1-to-1 and must have an inverse function. That's exactly how we define the inverse function. If f inverse is the inverse function of f of x, both fx and f inverse must be 1-to-1 function, of course, otherwise they won't have corresponding inverse function. And of course, that also means your inverse function is supposed to be unique, so you can only find one inverse function for it. This is supposed to be something that's unique. If you have multiple of those, what's the point of defining a limited to 1-to-1 function? So the next couple of problems express the sum of a non-zero number and its reciprocal to a function of the number. So your expression of sum, you are having two parts. So clearly you want to x and its reciprocal. It did say I want it to be non-zero, so you have x does not equal to 0 in this structure. The next thing is you want to express the parameter. In order to express the parameter, what you want to do is you want to sketch the graph to help you understand what's the key variables. And it should be x on one side and 1 on the other side, so you can find your parameter very easily. And one more time, for both problems, what I did is I started from identifying what exactly is my goal and I move forward from that. So once you have 2x plus 2y, we know you only handle one variable, so you either get rid of x or get rid of y, either one works. So what you do next is you go back to look at your problem and try to find a way to express y in terms of x or x in terms of y. The only thing that's given to me is an area, so area is the width times the height, so it's x times y, so it's up to you how you want to rephrase it. If you were to keep x, you have 2x plus 2 times 400 divided by x. So you end up with 2x plus 800 divided by x. You don't really have to simplify because x represents a side of your rectangle. It makes perfect sense to make sure that is something that's defined as positive. The next problem here is I actually have a kite here which consists of several pieces of plastic. The outer frame actually is some kind of plastic which we marked as 1, 2, 3, 4 pieces, and then we have 2 inside layer and they have perfect symmetry. It's 2 feet, 2 feet, 3 feet, 3 feet as marked here. So what I want you to do is my goal again, express the area. So your goal is to identify the area, and since I've already plotted the graph here, which is essentially 4 pieces add together, so you need to find all those 4 pieces. Because each piece is a rectangle, so what you could have said is I have this as a height of y, I have that as a height of z, therefore their areas 1/2 of base times height. 1/2 of base times height, so you find the area of this piece and that piece, and of course you want to find the area of this piece and that piece. That's 2 more, so it's 1/2 of x times z, 1/2 of x times z, which you can easily simplify as xy plus xz. As before, you can only have one variable, and because they've already identified for you that I want to use my x, so you want to find a way to express your y and z in terms of x. If you look at the problem, what you have here is your y and your x and your 2, which clearly forms a rectangle, right triangle, and therefore you have your Pythagorean theorem, which means x squared plus y squared is supposed to be 2 squared, where you know for sure y is greater than 0, so y is 4 minus x squared, take square root, and you are keeping the positive piece of it. Along the same line of thinking, you could have picked a right triangle from the other one, which tells you that equivalently z is 3 squared, which is 9 minus x squared. Therefore, you can draw your final conclusion. It's x times square root of 4 minus x squared plus x times square root of 9 minus x squared. Be a little bit careful that you should have your x to be greater than 0 because it represents a length of one side. But I also want to point out to you that because it's part of a right triangle, therefore this side should be less than the diagonal entry. Hence, sorry, hypotenuse. So this one should be less than 2 as well. So this is some extra information you may want to consider to building into your modeling, which is not required, of course. So the last problem is the most complicated one, because it needs the property of symmetry in triangles. So what we have here is I have a 10 feet wall, which is standing in front of 5 feet away from another building. So this is my wall, which is 10 feet, and it's 5 feet away from my building. So what I want to do is I want to put a ladder on top of it. So this is my ladder. And what I want to do is I want to find the size of my ladder here. Well, clearly it's part of a right triangle in my discussion, see here. So what you want to do is you want to make sure you can capture the behavior, and in order to find that part, what you're going to get is you're going to assume this is something that is also something. So this is x, that is y. So your goal is to find the length of your ladder, which means you have square root of x squared plus y squared, which is your final goal. But of course, it's not sufficient because you have two variables here. The question now is how can you rephrase your y in terms of x? Just like I said, it's part of the right triangle you have here, and you have another vertical line here. What you identified is this is 10, this is 5, this is x, that is y. Therefore, you may realize right away this side is y minus 5. That's two similar triangles you are playing with. By that, I mean the first one is the one outside, which is this one. The one inside is the smaller one, which is this one. That's two similar triangles. So the ratio between the corresponding edges are supposed to be the same. So 10 x over 10. So x over 10, which is the base of the higher, larger, and smaller triangle, is the same as the ratio between the larger one, the other right side, and also this one, which is y minus 5. So there are different ways to work this out. If you were like me trying to be lazy here, it's easier to find x in terms of y. So I'm just gonna say x is 10y divided by y minus 5. Basically, I multiply 10 to both sides. So what you could have get is it is 10y over y minus 5 squared plus y squared. This is one way to look at it. If you are more traditional, you may say, okay, usually we try to find the y in terms of x, and I do think it's a nice practice. So I'm just gonna go over that idea as well. So in order to achieve that goal of discussion, what I'm going to do next is I get rid of my denominator because I want to single out y by itself. So this is what I end up with. Once I get to that stage, I realize y cannot be moved together directly because it's buried in a parenthesis. So I have xy minus 5x, which is 10y. So now I can move them together, which is 10y, xy minus 10y, which is 5x, hence y times x minus 10 is 5x, hence y is x minus 10 over 5x. So your other choice is to get rid of the y from your expression. So what you could have said as another way of looking at the final answer would have been x squared plus x minus 10 over 5x squared, both of which are correct final answers. It's up to you which one you would like to choose as the appropriate one. Both cases, you want to tell me that x or y, if you want, are greater than 0 for sure, and your x, because it's standing behind that, so your x should be also actually be larger than 10. Or the other way around, you should say your y is greater than 5, not just greater than 0, but that's not my biggest concern. My biggest concern is can you build your equation and find the length of the ladder properly, which requires you to be comfortable with the similarity between two triangles.